In this video, we are going to define buffer solution and describe how buffer solution controls its pH. Buffer solution. Definition. A solution that maintains its pH when a small amount of strong acid or strong base is added to it. It contains weak acid or weak base with salt that has its conjugate pair. For example, if a buffer solution contains weak acid, the solution must also contains a salt that has the conjugate base for the weak acid. There are two types of buffer solution: acidic buffer solution and basic buffer solution. Acidic buffer solution. The solution has pH less than 7. An acidic buffer solution is made up of a weak acid and its salt that contains a conjugate base. As an example, a solution of CH3COOH and its salt, which is CH3COONA. If we look at the formula of the salt, CH3COONA has CH3COO-, which is the conjugate base for CH3COOH. The dissociation equations for the weak acid and its salt is as follows. CH3COOH is a weak acid that dissociates into H+ and CH3COO-, while CH3COONA dissociates completely into CH3COO- and Na+. Since CH3COONA dissociates completely, it produces high concentration of CH3COO-. The equilibrium will shift to the left. Then, less CH3COOH dissociates. The solution now has high concentration of CH3COOH from weak acid and its conjugate base ion CH3COO-. Okey, so kalau tengok dekat sini, dua equation ni, dua-dua akan produce CH3COO-. The first equation adalah equation yang reversible. The second equation, dia tak reversible. So, CH3COONA dah tak ada sebab dah dissociate kepada CH3COO- and Na+. Concentration CH3COO- sangat tinggi, so dia akan menyebabkan the first equation tu akan shift to the left, shift ke arah reaktan balik dan menyebabkan CH3COOH less dissociate. Maksudnya CH3COOH yang dissociate kepada CH3COO- akan patah balik jadi CH3COOH semula. Dan ini menyebabkan the first equation akan ada CH3COOH yang banyak and the second equation menyebabkan akan ada banyak CH3COO-. Sebab tu kita kata the solution now has high concentration of CH3COOH from the first equation and high concentration of conjugate base ion CH3COO- from salt daripada second equation. Apa jadi bila tambah acid ataupun tambah base? When a small amount of acid is added, conjugate base in this case CH3COO- will react to neutralize the acid. Conjugate base akan bertindak balas untuk neutralkan balik asid yang kita tambah tadi. So, apa yang berlaku? CH3COO- akan bertindak balas dengan asid iaitu H3O+ dan akan menghasilkan CH3COOH dan juga water. The amount of weak acid akan bertambah sebab dia menghasilkan CH3COOH, but since CH3COOH adalah weak acid yang mana dissociation dia adalah sangat kecil, maka the pH of the solution is not much affected. Disebabkan walaupun equation yang atas ni menghasilkan CH3COOH, tapi disebabkan CH3COOH ni ada dissociation yang sangat kecil sebab dia adalah weak acid, maka pH solution pun tak akan berubah banyak. Macam mana pula kalau kita tambah base? Kalau kita tambah base, weak acid, in this case CH3COOH, will neutralize it. Kita akan ambil acid pula yang akan bertindak balas untuk neutralizekan balik base yang kita tambah. So, equation dia CH3COOH plus OH- akan produce CH3COO- plus water. The amount of weak acid CH3COOH akan decrease a little and high concentration of CH3COO- akan bertambah, tapi disebabkan ada banyak concentration of CH3COO-, equilibrium position akan shift ke arah kiri semula and replace the amount of acid used to neutralize base tadi. Okay, so equation ni akan menyebabkan CH3COOH berkurang. Tapi kita tahu solution buffer acid ni ada high concentration of CH3COO-. Ini akan menyebabkan equilibrium position shift semula ke arah reactant and replace semula amount of CH3COOH yang digunakan. So, the pH of the solution is not much affected. Basic buffer solution. Basic buffer has pH greater than 7, and this solution is made up of a weak base and its salt that contains the conjugate acid. For example, a basic buffer solution of NH3 as weak base and NH4Cl as its salts which contains the conjugate acid. If we look at the formula of NH4Cl, we will get NH4+, which is the conjugate acid of NH3. The dissociation reactions are NH3 plus H2O produce NH4+ and OH-, while for the salt, NH4Cl will dissociate into NH4+ and Cl-. So the first equation is a reversible equation, while the second one is a complete dissociation reaction. So the second equation will produce high concentration of NH4 ions. So this high concentration of NH4 ions from the second equation will shift the equilibrium position of the first equation to the left, which makes the NH3 less dissociate. Faham? Second equation menghasilkan high concentration of NH4+ sebab dia dissociate completely. So, this high concentration of NH4+, kita akan apply pada first equation. NH4+ akan shift the equilibrium position to the left and produce NH3 semula. So, menyebabkan NH3 less dissociate. Bila less dissociate, maka kita akan ada banyak NH3. So, this buffer solution has high concentration of NH3 from weak base from the first equation and its conjugate acid ion NH4+ from the salt daripada second equation. Apa jadi kalau kita tambah asid dan juga base pada basic buffer? When a small amount of acid is added, weak base, in this case NH3, will react to neutralize it. Kita akan ambil base untuk neutralizekan acid yang kita tambah. So, equation NH3 plus acid yang kita tambah H3O+, dan dia akan produce NH4+ plus H2O. The amount of NH4+ will increase a little. Daripada equation tindak balas tadi, concentration of NH4+ akan bertambah. Tapi disebabkan dalam solution tu memang dah ada banyak concentration NH4+, maka equilibrium akan shift to the left and replace the NH3 use. Dia akan shift semula ke arah kiri dan menggantikan semula NH3 yang digunakan dalam tindak balas tadi. So, ini telah menyebabkan pH of solution is not much affected. Dan yang kedua, when a small amount of base is added, conjugate acid NH4+ will react to neutralize it. Kalau kita tambah base, conjugate acid pula yang akan bertindak balas. So, reaction dia NH4+ tambah OH- akan produce NH3 plus H2O. So, ini telah menyebabkan the amount of NH3 to increase a little. Concentration of NH3 akan meningkat sedikit, tapi disebabkan NH3 ni adalah weak base, so dia punya dissociation adalah small, sangat kecil sebabkan dia adalah weak base. So, the pH of the solution is not much affected.